Hey ladies and gentlemen, we're now going to show you a demo of our latest creation called the Colossus. Let me introduce you to my colleague Andrew. Say hello, Andrew.
Oh.
Alright, so he's playing his video games. Anyway, our latest creation, Colossus, is like a prototype for a radio telescope. And basically what it does is it records the volume of the sounds surrounding it, and then it draws a graph. Basically.
So this is what the Colossus looks like. We name it Colossus because it's rather big compared to the other creations we've made. And you can see we're using Lego Mindstorm NXT 2.0 to build the Colossus. We're using all the three modders here. They all have different functions. Two of them are drawers, and the other one is basically it rolls down the paper so that we can draw on the paper. And the blue one is actually the first one that we built. But later on we decided that it was not good enough, so we built a second one. And it's now using the black pen, so we can compare them.
So the process of designing, building, and then improving the Colossus took about 2 months. And as we said, it is actually a prototype for a radio telescope. My colleague Andrew here happens to be an expert of radio telescopes. Now let's welcome him to give everybody a short introduction of it, shall we?
Hi. So radio telescopes mainly receives waves from outer spaces. And so we can gather it from one point. By analyzing its amplitude and also the wavelength, we can identify the presence of different kinds of stars, like pulsars, for example, this kind of crazy things.
So this is our program. You can see it's divided into 3 individual parts, here, here, and here. First of all, the simplest part here with only one module. It is the motor down here. It rolls down the paper with a constant velocity so that we can draw a picture on the paper and show different amplitudes of the sound. And here the second one, the second part of the program. It is the blue pen one here. Because of its special mechanical structure, we can let it simply go in one way without going the other way. And it will draw a very beautiful image for us. And you can also see we're transforming the volume of the sound into the power output of the motor, so that when we have different volume of the sounds, it will draw at different velocity, like different speeds. And here, the last part of the program here, it is a little bit more complex than the previous one, but still very simple. You can see we're still converting the volume of the sound into the power output of the motors. And it is used in this part of the our Colossus. You can see because of its gears and others, so we need to let it go back and forth, and that's why we have 2 moving modules here. So here comes the most exciting part. We're actually going to show you a short demo of how it really works, starting the program right now. So be quiet at first so that we can show you the difference when we have different volumes. Alright, you can see it's quiet right now, but as we increase the volume of our sound, it's actually, its amplitude is increasing, and as we quiet down, it's... So here's what we got. Then it's smaller. You can see different amplitudes, different frequencies and stuff.
So the reason why we built the Colossus was that 2 months ago we were doing a science project about radio telescopes, and we thought to ourselves, if we could build a real telescope, or at least a prototype of it, we could absolutely have a better understanding of it. So we drew a blueprint, built it out, and improved it in a variety of ways. Like, for example, adding a second pen here. And after that, we thought to ourselves, like, learning, the fastest way to learn something is to actually apply the knowledge into a real life use. And yep, I think that's all. Thank you very much for watching, and hope you enjoy it.